grades proposition, so you will know whether you need to take the test in 2 weeks or not. Okay, is it okay? Hello?
Yes, I think that's the good plan.
Okay, thank you. So let's start with the exercise. I think it was the 7th one, but this one is quite easy. I think everyone did it. So maybe let's switch to the 8th one, exercise 3.8. And give me a second to switch to my list. Hey, give me a few seconds. I want to choose the person that the points can change the grade better. Okay, let's try with Hadrysiak. 1 second, I forgot to enable screen sharing, and now it should be fine.
Okay, so I will share my screen. Can you see my screen?
Yes, we can.
Okay,
I can, at least.
So I start with coding 3 states with 2 repeats, and later make a table of state transition, which is quite easy because to get from state 0 to state 1, we need only A input. Into state 1 to state or 2 or 0, it's only B, so rest is don't care. And later I defined a queue with states, and this is the equation, and the circuit looks like that.
Okay, give me a few moments to check, because of course that I used different naming, so. Okay, it looks fine. Everyone agrees? I think it's correct, so thank you.
Thank you.
Everyone had a time to take a look? Okay, so let's go to the next one if no one's saying that he needs to take a look more. So the 9th one. And again, my list. Okay, let's do so that one, we have 2 tasks coming. So one will be done with by, if it's okay for you, by Piechowski, and the second one will be done by Zatan, okay? Because you have the same amount of points and I want to give you even chances. So maybe let's start with the first that I mentioned, okay?
So task 9, right?
Yes.
Okay, let me share my screen. Okay, can you see it?
Yes, we can.
So we have another finite state machine here, just as in the previous task, but this time it's a Mealy machine and not Moore. So the outputs depend both on inputs and current state. Hence this slash, and this is output. This is corresponding input, this is output, this is which is state. So the state transition table is like this time is combined. It's both future states and outputs here. And like it's pretty much straightforward. What happens here is if A is 0, then we don't care about B, and from S0 we stay at S0. If A is 1, we don't care about B as 1, and so on. And Q is only 1 in this case. So when we are going from S2 to S2, and both A and B are equal to 1. So that's it. And I've chosen the most basic binary encoding, so 000110. This is written transition table with binary encoding. And these are the equations. I didn't do K-maps because they are like easy to see. This is like not S1, S0, we don't care about A and B, plus S1, not S0, A and B. Or it should be B, not B. But and this is only not yes and dot care, and Q also yes, no, yes, and yes. And this is the design.
Okay, please scroll up so we can see once again the S1 prime, S1 future. Take a look at the second, the part where you mistaken B with B.
Yeah. I see that. This should be here, not, and this.
Yes. Two things. This one and the one you mentioned. Okay.
Yes,
so it's correct. So everyone had the time to look at it, because it usually takes a while. Just let's wait 30 seconds so they can all compare. Okay, thank you.
Thank you. Yeah, great enough.
And the next one, as I said, Zatoń. I'm the only one raising her at this point.
Okay, so 3.10. Here we should upgrade the finite state machine from the lecture. And I had to add 2 states with both lights red for 5 seconds. So it's the state 2 and state 5. And I have added also the additional signals TB and TD in order to have like 5 delay seconds. So what I wanted to achieve was that for time less than 5 seconds, when achieving a signal TB, this state will continue, and after this time, it will proceed to the next state.
Okay, sorry, let me interrupt you for a second. You had this machine explained for you by Mr. Budzin during the lecture, right?
Yes.
Did you find the source of this task? Well, the source for almost all the tasks that we use. It's one book. I am sure that Mr. Budzin.
Yeah, Mr. Budzin mentioned it. It's the digital design and computer architecture.
Yes, that's correct. And if you maybe he forgot to mention it, I'm not sure. But if you looked at the source text, that
the period of the clock is 5 seconds here.
Yes, so you don't need the additional signals to keep them on for 5 seconds, because the change occurs in 5 seconds.
Yes. Okay, and that's what I wanted to ask you, if this is necessary.
It's not. It complicates the. Actually, if you aim to wait for 5 times for the transition, it will be even more of a delay. So it complicates the task, of course, because you have more signals. So it's a lot of counting after
yes,
that.
so actually for this T, B, and TD everywhere will be just don't care. So
Yes, for every single only in 2 places there will be not don't cares.
yes, so the encoding of the states will remain the same. It was just simple encodings according to indices. And to encoding of lights, so green, yellow, and red. And for the state, for states 2 and 5, we will have just simple don't cares. So this will be thrown away, and this also. And instead of here state 5 and state 2 coming back, it will be just proceeding to state 3 after 5 seconds and to the state 0, so the beginning. And according to this table, with encodings and encodings of outputs, we can fill this final table of states, of course, without the state S2 and everywhere don't curse.
Okay, your solution, if we assume that we want those additional signals, looks also okay. But I wanted someone, is there someone who has the correct one so we can see the tables without the changes? You got, of course, full points. So.
Okay, thank you.
Maybe Podkowinski, I know you are not raising hands. Do you have it, maybe, by chance?
No, I don't, unfortunately.
Okay, no problem. You are also on the, border of 2 grades. That's why I asked. Okay, so anyone?
I mean, I have it, but I just been throwing.
Okay, you can show us.
Okay. Okay, can you see my screen?
Yes.
So it's like the only difference between what was on the lecture or in the book is that we have these additional states S2 and S5, in which both reds are both lights are red, and they don't really depend on any input that goes here for one period of the clock and then goes there. This is checking if there's still traffic on this road. This is when it's not, and like just on the previous example. State transition table is like that. It's a little bit less complicated than Jakub's because of this less obsess of this C and the D.
Yes, he also explained it. So
yes, binary state encoding like usual, output and encoding also as usual, and this is as usual.
Okay, so if you could show us the whole page that we are on, the whole content. Yes, and let's give a few minutes for the people. Not only this page, I think that the previous one is easy enough that everyone did it. So let's give everyone a few seconds to take a look at it without the word changes, and so they can compare or do a print screen so they can analyze it later.
Of course.
Okay, so thank you. And we'll go to the next one now. Okay, the element we will, let's leave it to the end of the lesson. The 12th one is easier. So the last exercise, 3.12, who wants to do it? I think it's the easiest one from this part of the list. Anyone? Okay, Perliński.
Okay, this one. Okay, so we had to design a counter from 0 to 7. So first I wrote the states, but for binary. So we use 3 bits, so it looks like this. Then we have the next state. So basically 0, 0, 0 goes to 0, 0, 1, which is 1 in decimal. And then I coded the output in the gray. So Q is in gray. And then I just wrote the K-maps for each S next. And yeah, it looks like this.
Okay, give me a second to check why it was easier. It was easier than the previous one because it didn't have the additional signals.
Yeah, so
the maps were easier. And okay, everything looks fine. Everyone agree?
Yes.
Okay, thank you very much.
Okay.
And let's look at the additional exercise. I name it additional, but it's not that complicated. It's just time consuming. So anyone did it? Zatan?
Okay, I can show you, but I think that my solution isn't okay. So it's truly complicated because we have like many possibilities to put in the coin to the machine. So we have the first state, which is wait and dispense maybe. So what we can do in this state, we can do nothing and just wait for the person to put the coin in, or we can maybe put the coin of quarter, so like 25 cents, which is the value which we expected to dispense the can. Then we can dispense it and turn back to the wait state. I also saw that people done dispense and wait according to signals. I just wanted to make the separate state. We can then put the 5-cent coin, and then we have also many possibilities because we can put again 5 cents achieving 10 cents, or maybe 10 cents achieving 15 cents, and maybe 25 cents achieving 30 cents, and return of nickel, which is 5 cents. And in the same manner, I made all the states, and they ends with different return states, 2 dimes, 1 nickel, or 1 dime. Unfortunately, I don't have one state which is 1 dime and 1 nickel. And in the, I don't know if in the task it was said that it should be also done, but I haven't got it, unfortunately. And here the encoding of the states is by indices, and the state 00 of the dispense is like state 12, actually. And here I have all states written down. from the state 0, which is wait, achieving no signal, so all negated, we wait for the coin. If we achieve the signal dime, then dime was inserted and we can proceed to state 1. If the quarter was inserted, we can proceed to the state of dispense. And of course, dispense with don't care turns back to the reset and state 0. And in the same manner, all next states. And the coding of the outputs is for quarter, it's dispense, wait for all negated signals. For a quarter and dime, it's dispense plus dime, because we have to return this dime, etc., etc.
Okay, so the method is correct. Whether it's this whole solution is correct, it would need a little bit more of getting into it. So we'll have to
Yes, that's true.
spend some time. That's what it's considered the additional one, because I also think that there's more than one way to do it. The question is which one is more or less complicated. So thank you very much. I gave you points, and now. Please give me like 5 minutes to update my list. Okay, so I will update it. I will upload on the app portal the proposition, and we will have time to take a look into it. And if there will be questions, I will wait for you here, and so you can ask. Okay. If you don't think that you will have questions, you can of course leave, but please give me 2 minutes, because I also want to check the present. Does anyone knows what happened with Kvolek? If you know and can give me some idea, please write it on the chat to me privately, okay? Whether he will be or he won't be. Thank you. Okay, so I finished with the presents. So if you don't think you will have questions, you can leave. Also, you can just check the proposition in like 5 to 10 minutes on a portal, and you can reconnect also if you feel that you need to discuss something. And in the meantime, I will upload the grades on the portal.
Excuse me?
Yes?
I was late 5 minutes. May I ask when can we expect the test?
Okay, yes, I forgot about it. I gave you the question on the portal, whether you had two options about the test, and the one that won is that the test will be on yours next lesson, and the retake will be on the last lesson of the second group. So it will be Monday after Monday. So the test will be in 2 weeks, if I'm correct.
2 weeks.
Yes.
Okay,
Yes.
perfect. Thank you.